Corporate Finance Core, Topic 5, NPV and IRR. Learning objective number 2. We're going to compute the most common measures used to evaluate investments. In the first topic, we calculated unlevered free cash flows. Those are the cash flows available to pay both debt and equity holders, or the cash flows generated by an all-equity finance project. In this topic, we're going to look at a bunch of measures used to try to summarize that data and make a decision whether you're going to green light or go ahead with the project or not go ahead. So the the measures we're going to do are average accounting return, payback period, discounted payback period, net present value, also called NPV, profitability index, and the IRR or internal rate of return. So we'll start with the average accounting return. So I'm going to first calculate the ROA each year, which would usually be the net income over asset balance, on the balance sheet. However, in this example, I'm going to use the EBIT after tax, the EBIT after tax, and that is my net income if I have no equity or no debt financing. So I'll take my EBIT after tax and I'll divide by the book value of assets and get a yearly ROA, return on asset. And to summarize that in one number, the average accounting return, I'm actually going to take the average of all the EBIT after taxes, or again, net income if you had interest expense in there, divided by the average book value for all years. So let's go into the spreadsheet. I'll calculate my ROAs, profit divided by book value of asset, copy across. So it varies from 10 to 48%. And then I have calculated here for you already the average accounting return, which is the average profit divided by the average asset balance for the life of the investment. So that is the average accounting return. So how could you use this to make a decision? Well, you have to come up with some benchmark, like we only accept projects with a 15% average accounting return. And if that were the case, if that's your benchmark, you would accept this project since your project's return, average accounting return, it would exceed that benchmark or hurdle rate. So let's talk about actually a popular measure called the payback period. And it looks like cash flows, that's a benefit, not just profits. And it looks at how many years does it take to break even, not accounting for time value of money. So it's literally how many years am I go from in the red to in the black. In other words, go from a kind of a deficit, cumulative deficit, to a profit or positive cash flow. So I'm just going to calculate the cumulative cash flows right here. So what I'm going to do is I have a link to the number above. So I start off today, 165 in the hole. I'm then going to have a link to that number, and I'm going to add the number above. In the end of the first year, you've made 31,448. So at the end of the first year, you're 134 in the hole or in the red. So the question is, what year does it turn non-negative, turn positive? And that is year 6. So in year 6, this cash flow is positive. That's why I've written here 6 years. So how I use this to choose this an investment or a project is I first have to determine what is my minimum payback period. So I might say I only accept projects, I'll accept all projects that make a payback in 5, 6, 7, 8 years. And this payback is 6 years. So if that was less than your minimum payback year, you would accept it. A slight improvement to this measure is the discount payback. So the problem with payback period, it doesn't use discounted cash flows. The cash flows in year 8 are valued just like the cash flows in year 1. So what I'll do is I'll take the present value of cash flows and then get the cumulative present value of cash flows, and then I'll see when it breaks even. And for this, I'm going to need a discount rate. So let's just make up a discount rate of 12%. So right here, I'm going to have the present value of cash flows. So I'll take my free cash flow, 165, divided by 1 plus my discount rate, anchor that, raise to the 0 power. Up here is a link. I'll copy that across and I'll then take the cumulative present value of cash flows by just having a link above, link to the left plus the number above. So I start off at 165 in the red, then I'll copy across, and looks like the first year that it turns positive, or at least breaks even, is year 8. So my discounted payback is 8 years, and I accept that project as long as you're accepting projects that say have a less than a 10-year, say, discounted payback period. So that's discounted payback. Let's talk about net present value. Net present value is just the sum of the present values of all cash flows. Pretty simple. So if I just take my present value of cash flows, notice I have present value of cash flows right here. Actually, if I select them all, I can look down here. The sum is 11,356. Or I could just sum them up right here, the sum of all cash flows in present value terms. So that's my net present value, 11,356. It's in dollar terms. And the net present value also has a function, NPV, although be careful with the function. Here's how you do it. Equals NPV, first parameter is rate. Second parameter, notice it says value 1, value 2, value 3. It doesn't say value 0. So it actually starts with the value, say, at the end of the first period to the end. So notice I have NPV, open bracket, the rate of 12%, comma, then I just have the future cash flows. So it starts with the 31 and goes to the 82. And then outside of the NPV function, I actually have to add today's cash flow. So it's actually a little bug in how they actually program the NPV function. And you always have to skip the cash flow at period 0 and start the NPV function with the cash flow in period 1, and then add back today's cash flow. So that NPV is 11,356. So how do I use NPV to decide if I want to accept the project? You have the investment rule of accepting all projects in which the NPV is greater than or equal to 0, which seems very odd. Why would I accept a project that has an NPV of 0? Because let's think about the calculation. By discounting the cash flows at 12%, and then summarizing and taking a summation of all the cash flows, if the NPV were exactly 12%, if the rate of return were exactly 12%, the NPV would be 0. So let's think about that a little bit. When the NPV is 0, you've earned exactly 12% return. So if you're requiring a 12% rate of return for this project, an NPV of 0 means you've got it exactly. So if the NPV is actually greater than 0, you're getting something greater than 12% rate of return. So you need to make sure that discount rate 12% is the minimum that you would accept for the project. Let's now talk about one of our last measures. We have 2 left. Profitability index, very close to NPV. It is NPV, but it shows it as a ratio instead of a dollar amount. So the profitability index just takes the present value of all the future cash flows after your initial investment, divided by the initial investment as a positive number. So it's just the sum of all these numbers divided by 165. So if I go here, you can see that it's the sum of the future cash flows in present value terms, not in nominal terms, divided by negative 165. So it's the sum divided by 165. And notice the number is 1.07. If the number was equal to number 1.00, what that means is the present value of future cash flows is exactly equal to the initial investment. And what that would signal is the NPV is equal to 0. So if you have a profitability index greater than 1, that means the NPV is greater than 0. So I would accept all projects that have a profitability index greater than 1. Why some people prefer this is if you're looking at 10 or 15 projects, you're deciding which ones to do. It kind of gives you an equal footing to kind of look at the indexes. 107 looks better than 103. So it kind of gives you an idea of the rate of return of the project. But actually, most people, if you're looking for rate of return, use the last measure, and that is IRR. IRR is the internal rate of return. two interpretations. It is the average annual rate of return, approximately. And it's also the discount rate that makes the NPV equal to 0. Now, there are two ways to calculate IRR. Number one, you can do a goal seek. Once you've computed NPV, do a goal seek. Data, what if, goal seek. Set the NPV to 0 by changing the discount rate. Hit OK. Notice that goes to 1372. At 13.72% discount, the NPV is equal to 0. So a way of thinking about it is if I discounted the cash flows at 13.72%, my NPV is 0. So what I'm actually earning is 13.72% per year. The other way to do it, a little bit easier, equals IRR, and put in all the cash flows, including the initial -1. And so there it is. So how would I use IRR to determine whether we're going to do a project? Well, you accept all projects in which the IRR, the project's IRR, is greater than some hurdle rate, sometimes we call it, or the required rate of return. So if I say this project's based on its risk, should return a 12% rate of return, this IRR is 13.72, then I'd say I would accept this project. So it's just another way of thinking about NPV. Instead of calculating the value in dollars, it calculates it as a rate of return. And generally, the IRR will give you the same answer as the NPV. Remember I said the NPV, you accept all projects that are greater than 0, and for IRR, you accept all projects that are greater, that have an IRR greater than that discount rate or hurdle rate. It almost always gives you the same answer, given the same set of cash flows, but there is a caveat, and that is there's a chance that IRRs could have two values, and the functions in Excel won't be able to figure that out for you. So, but it only happens when there's two changes in signs. So notice a simple project right here. The first cash flow is I spend 100, then I get 230, then I spend 132. So if I calculate if I look at what is the NPV at a 0 discount rate? Well, it's losing $2. What is the NPV at a 10% discount rate? It's 0. Oh, that must be the IRR. However, I also, at a 20% discount rate, the NPV is also equal to 0. So there's two solutions to this problem. The IRR is both 10% and 20%. Both numbers mathematically will set the NPV equal to 0. So in that case, whenever you change signs more than once, cannot use IRR, default to NPV. Also, well, let's talk about this. Which measure is best? So for those that organizations are run by accountants, they love average accounting return. If they're focused on looking at ROAs, this is going to tell you on average what your ROA is in some sense. If you have organizations are a little bit short-sighted or just have some short-term requirements, like we don't, our business is so risky, I don't know if I can wait for a 10-year payback, I'll use that. You have the NPV and profitability index, and so the advantage of them is they're looking at discounted cash flows and basically just summarizing discounted cash flows. They're basically the same measure, it's just whether you want to see it in dollars or a ratio. However, NPV will be preferred just because it's just more used in practice, and you can see a dollar amount. And then you have IRR, which generally gives you the same answer if you're trying to figure out whether you should do the project as NPV. Except IRR, everyone loves a rate of return, and everyone knows that a 40% rate of return is an awesome rate of return, and -1 is a terrible rate of return, or 1% is a terrible rate of return. So people like rates of returns, and usually I'll look at both of them when I'm looking at projects. And also, in some organizations will actually calculate all of these. And maybe NPV and IRR are their two main metrics, but maybe kind of a tiebreaker might be one of these other metrics. Especially if you think about payback period. Sometimes when I did this for a living, I would calculate NPV and IRR, and I would calculate payback period or discounted payback period. And if two projects had similar NPVs, but one project has a 5-year payback period and one has a 15-year payback period, I'll just probably go to the shorter payback period. Not that I think financially is a better deal. I think actually it's just riskier to, as far as a model For all those things to happen over 15 years, so all else equal, I would prefer a shorter payback period. And sometimes I might just take a project with a shorter payback period, even though two projects may have similar NPVs. So in this topic, we talked about the common measures used in practice by corporations. Later, we'll talk about which ones corporations use the most.